Okay, Assalamu alaikum jami'an. Good afternoon. This is Abdullah Al-Baijan. I'm an officer with the ASME Eastern Saudi Arabia section. We're glad today to have host SMI, one of the leading manufacturing companies in Saudi Arabia. And we're fortunate to have not one but two of SMI members to share with us their company's accomplishments and capabilities and achievements, as well as having a deep dive in 3D printing applications. We have with us today Abdulaziz Al-Umar, sales engineer from SMI, and Faiz Al-Ahmadi, development engineer. Abdulaziz, you may proceed.
Thank you, Abdullah. Good afternoon, ladies and gentlemen. This is Abdulaziz Al-Umar, sales engineer from Saudi Mechanical Industries. First of all, on behalf of SMI family, I would like to thank the local chapter of American Institute of Mechanical Engineering in Eastern Region for giving us this great opportunity to present you this technical session, which we hope it will be a beautiful one. For me, I will start first part of the presentation covering SMI history and SMI summary. Then we'll move to our mechanical manufacturing capabilities. Then the mic will be moved to my colleague, Mr. Faiz Al-Ahmadi, which he will present you the 3D sand printing technology and its advantage. And then we'll be pleased to answer your question. Just to show you how SMI has developed its capability during the last 40 years. Starting from the establishment, there was several expansions, such as acquisition of the local sand casting foundry and getting a license from a well-known brand to manufacture their commodity here in the local. Until the last expansion, the recent one, which is establishment of valve manufacturing facility here in Dammam. Speaking of vertical expansion, SMI has fully integrated manufacturing facility to manufacture the engineering component and OEM projects. With total area of 118,000 square meters covering 3 major plants, 2 in Riyadh, 1 in Dammam. With casting capacity of 40,000 metric tons per annum. And to serve our customer from different locations, we have 8 sales warehouses here in the Kingdom and 2 other warehouses in USA. Such this facility which help SMI to serve its vision, which to be a leading local manufacturer and reliable source providing engineering component and solution to the customer. Moving to vertical integration, SMI has fully equipped engineering, design, research and development team with fully equipped manufacturing facility covering 3D sand printing technology and 85 CNC machine and machining hub and porcelain coating facility, which enables SMI to manufacture various types of equipment such as pump, valve, gearboxes, etc. And it's good to mention that SMI has its own pump test station with depth up to 100 feet with testing capacity to 1,000 horsepower utilizing electrical motor and diesel engine. I will examine the capabilities in details one by one. I will start with engineering department. In this department, we are doing 3D scanning and 3D modeling method of the casting process by designing the riser, feeder, gating system, etc., and simulation of solidification and simulation of the fluid and simulation of the machining. All this activity to avoid the rejection of the actual manufacturing and to enhance the efficiency of the manufacturing. So if there is any technical issue, it will be detected in the beginning before it reaches to the actual parts. Moving to better manufacturing, we have 8-axis CNC machine to manufacture the button tools before it's sent to the foundry and assembled to the button boxes and process the casting. And speaking of additive manufacturing, SMI has adopted advanced technology, which is a 3D sand printer technology to print the 3D print the 3D printed core and batter as well. Basically, what we are doing here, we are designing the core and batter, we install in the system, we print, clean it if required, then just send it to the foundry to be assembled in the batter box to process the cast. Or, as you can see in the right picture, This was back in 2019 when we participated in a Diriyah season by renting this stand and assembled different pieces in the site. Speaking of FERROUS foundries, we have two lines, fully automated system and regular welding lines. Initially, we start casting cast iron and ductile iron only. Then when we see the demand on more and different alloys, and we see that we are capable to cast, we start cast more and different alloys such as stainless steel 316 and 316L, carbon steel, WCB and LCB, and NI resist. And currently, we are doing trials to cast duplex crates. We are servicing different range of equipment engineering components, such as pump spare part, gearboxes, valve, turbine, etc. Servicing different range of market industries as well. Besides foundries, we have continuous cast bronze foundry located in Riyadh, which enable us to produce bronze product with different alloys, such as LG1, LG2, nickel aluminum bronze, tiger bronze, phosphor bronze. And since we are able to manufacture the die itself, which gives us advantage to manufacture it with different shape, such as round, hollow, solid, hexagonal, etc., meeting international standards. Moving to CNC plant, initially we start with only 6 lathe machines. Then we upgrade ourselves. We develop the machine, reaching to 21. We have more than 85 CNC machine and machining center, enabling us to do various types of machining, such as keying, tabbing, drilling, warming, etc. Not only our parts, also we can machine other parts if we bring the raw material from the local or the global market. We can accommodate small batches starting from 25 pieces up to big batches, including 10,000 pieces as well. Pump shaft finishing facility is another example of vertical integration, from complete importer to complete exporter. In the past, we used to brought this shaft from the global arena. Now we start manufacturing it in-house and export it to USA and Europe as well, with approximate 2,000 batches per year. To maintain this level of quality, we invested in quality assurance and quality control department, in which we have different stages in inspection and product verification, such as type entrant test, hydro test, and to get to mention, we have coordinate measuring machine, which is called CMM, enabling SMI to compare between the approved drawing against the actual manufactured part, which can be considered as a third party between SMI and the client, since the system will tell you if the part accepted or rejected based on the drawing. And for sure, by having this number of gauges and tools, we need to calculate all these gauges, either locally or if required, it will be sent to the global arena. The only pump test station in the region having borehole with depth to 100 feet is in SMI in Riyadh, enabling SMI to test vertical and horizontal pump with low and medium voltage, with testing capacity of 15,000 gallons per minute and 1,000 horsepower, utilizing electrical motor and diesel engine. I will move to our assembly line. First one is pump assembly line to assemble, test and bag the vertical turbine and submersible pumps. The drive line, which goes with vertical turbine line system. The recent one is for valve to assemble, test and bag the industrial valve to the clients. Besides manufacturing facility and capabilities, our crew on the site could support the customer by test, install, commissioning the different equipment, meeting his standard and to fulfill our customer requirement. In having such these capabilities, here is our standard product. We are manufacturer of submersible and vertical turbine pump under a license from National Pump Company, and we are supplying bronze product and round steel bar as well. And we are servicing different range of applications for engineering components such as irrigation, HVAC, oil and gas sector. And we are manufacturer of right angle gear drive under a license from Johnson Gear, and we are listed and FM certified to manufacture firefighting pump and we are manufacturer of section pump as well under a license from Bovat. Not only in the kingdom, we are proudly to say that we are exporting more than 70% of our product to the global arena, starting from Europe, USA, Ecuador, China, Thailand, what you have ever in between. And to serve our customer from different locations, as I mentioned, we have a sales branch here in the kingdom, in Al-Kharj and Wadi Dawasir, Riyadh, Dammam, Qasim, Sajir, Hayel, Tabarjat, and Tabuk. I always believe in technologies. Therefore, we complete 4 transfer program to manufacture the global commodity here in the kingdom. We have a license for national dam, fencing gear, Wabati, and Airflow. We will not stop to this point. We will keep doing a partnership and getting a license from well-known brand to manufacture their commodity here in Saudi Arabia, utilizing our great power in manufacturing and our export in the market. Here's some example of international recognition. We have ISO quality and environmental management system, and we are UN listed and FM certified to manufacture firefighting pump. Since we reach to the end of my part, for about in the previous slides, we have gone through semi summary and semi history and our different mechanical manufacturing capabilities. And now we will start a new journey with my colleague, Mr. Faisal Ahmedi, which he will focus on how 3D printing technology will improve the maintenance performance.
Thank you, Abdulaziz, for the overview of SMI. It's quite the company in terms of services, range, and volume. Before we move, does anyone have any question for the first part? Let me check the mics. Okay, I have a question for you, Abdulaziz. You mentioned that one of your services is after you manufacture the parts, you do assembly, and then you do the shipping to the customer or the clients. After
Yes.
the assembly, do you do the testing as well, or is the testing outsourced, or is it handled by the client?
We have various types, as I mentioned, of testing. We have the penetrant test, Some of tests, of course, if need to be done, will be done with outsourced, like certified third parties, such as NBI or any special test requested by the customer.
Okay, so that's even after the assembly of the manufacturer's part.
Sure.
Thank you, Abdulaziz. Any more question? Okay, we'll move to the next part for the 3D printing technologies with Faisal Ahmedi.
Okay, thank you, Abdulaziz and Abdullah, and good afternoon, everyone. This is Faisal Ahmedi from Engineering Department, Development Engineer. I will give you a brief introduction about how can 3D printing technology improve your maintenance performance. But before we starting our presentation, please raise your hand anytime if you have any question, and Mr. Abdullah will stop me and will transfer your question to us. Mr. Abdullah, can you please give me the control?
You're added as a presenter, Faiz.
Automatic. Okay.
Okay.
First of all, we will start with the contents. We will speak about the maintenance challenges, then the spare part, conventional manufacturing, additive manufacturing technology, the 3D sound printing technology, reverse engineering, and the 3D modeling technology advantages. Then we will talk about the 3D versus the conventional manufacturing, then the hybrid solution. Finally, I will show you some real case studies happened here in SMI. First of all, for the maintenance challenges, we all know there are many challenges besides performing the proper maintenance activities is to have the right spare part. One of these challenges regarding the spare parts is the delivery time, cost, and how expensive these spare parts, and sudden breakdown and the availability of the spare part especially for the old equipment, repeated failure due to bad quality of spare part. On this slide, I will show you the process cycle for the conventional manufacturing. But before we start on the process cycle, I would like to draw your attention here to what we mean by conventional manufacturing. In conventional manufacturing, we will follow the traditional way of sand casting, and there will be tooling and battery manufacturing, where in the full 3D printing, we don't need it for any battery or tool manufacturing. And back to the cycle, mostly in sand casting, and whenever the customer doesn't have the 3D model, cycle will start with the reverse engineering. Then we will build our tooling and battery manufacturing, casting, heat treatment, machining, finally the inspection. In this slide, I would like to introduce the 3D printing technology. This technology was invented in 1980s. Since that days, it was only used for prototyping purpose. However, in last few years, this industry has expanded and new technology is now available in the market. In next slide, I will show you some of these technologies. We'll start with the fused deposition modeling, used for plastic and polymers, has a limited strength and used for non-functional parts. Then the stereolithography, used for plastic and polymers and has a limited strength and used also for non-functional parts. Selective laser sintering, used with the stainless steel, aluminum, titanium, or cobalt, or chrome, has a limited in building volume and used for functional parts. Finally, the binder jetting, ceramic and metal or plastic, has a least limitation and used for functional part. SMI proud to say that we have this technology, which is a binder jetting in our system. And in next slide, I will show you how this technology works. First of all, once we got the program, we will transfer it to the machine. The machine has two main parts. One is called the sand coater, and the other one is the printer head. The sand coater will start laying layers between 0.2 up to 0.5 millimeter in thickness. Then the printer head will move according to the program that we have provided. After that, the platform will go down to give chance to the next layer to be built up. Step 2 to step 4 will be repeated. And finally, you have your own finished part. Regarding this technology advantages, no tooling required and the shorter delivery is being given to you. It is totally geometric freedom and can be used with wide range of materials. Let's see now the conventional and the 3D printing comparison in terms of time consuming. You can see here two lines. The first row is for the conventional and the second row for the 3D printing. In conventional, the cycle will start with the reverse engineering and the 3D modeling. It will take around two weeks. Then the pattern design and manufacturing from 12 to 14 weeks. Mold preparation and metal boring will take 2 to 3 weeks. Casting, machining, and inspection will take 2 to 3 weeks. In conventional, as you can see here, the majority of the time consumed is going for the pattern design and the pattern manufacturing. Whereas in the 3D printing, we can eliminate this loss and we can save around 12 to 14 weeks. In terms of the geometric freedom, as known, whenever the part is geometrically bonded, the cost of manufacturing will be very high for the conventional manufacturing or traditional manufacturing, whereas in the additive manufacturing, the cost is constant, and hence you can see the graph which can represent the cost effect. Now we will start with the first case study, what SMI have done for real time for oil and gas field. This one in pillar with a 25 diameter and a weight of 90 kilogram, produced from CA6NM. It was manufactured through the hybrid way, which hybrid is nothing but it is a combination between the conventional way and the 3D printing. We have manufactured here the pattern, but in the same time we have printed the course. This is the process cycle for this project. Here on the left side, the moment the sample arrived at SMI, it was literally nothing. Our design team did the reverse engineering, and then they got the 3D model. And they also have built the 3D model for the pattern, then casting, machining, and finally it was shipped to the customer. These some pictures for the printed cars used with this project. And here the time calculation using the traditional way and time calculation using the hybrid way. Although the cost is almost the same, but however, the substantial improvement was on the time delivery. We have done this project in 13 weeks instead of 20 weeks for the conventional manufacturing. And here the second case study, which was fully 3D printed job. It is also for produced for oil and gas. It was upgraded from cast iron 30 to carbon steel with total height 11.8 and weight of 13.7. And here the process cycle for this project. You can see in the left side the picture for the component, and just below the component that we have received in SMI, and just below this pictures, you can see the component that shipped to the customer. And here some pictures of the 3D mold and 3D course that we have printed for this project. And for the time calculation, and the interesting thing here I would like to represent is the time saved for this component. This component was fully 3D as mentioned before. Molds and cores were printed and the project was completed within 8 weeks, while in the traditional way it may take 20 weeks. And if you look on the right side of the cost graph for both ways, as you can see, the cost is not that high for full 3D comparing to the time saved for this project. And even for the low quantity, up to 3 pieces, the cost is much higher for conventional because of pattern manufacturing and tooling cost. And once we move forward with the quantity, the conventional manufacturing will be depreciated. That's why additive manufacturing technology, for most of the time, if we are targeting low quantity, will be more suitable than conventional manufacturing. And here I would like to show you the machine installed in the SMI facility. We have a Sandy 3D printer from X1 company with 2 job boxes, each with a build volume 1.8 by 1 by 0.7 meter. But however, we are not limited to this specific size because we can do a segmented job, and these segmented prints can be assembled beyond this size. Here some pictures of the 3D core and that were produced by the X1 machine. And now I will show you some project executed by also by the X1 machine. Here we have the double section impeller. It was for fuel pump. And as you can see, the customer sample on the left side, it was totally damaged. And just on the right side, the manufactured component. This is the second project, pump case and stepping box used for hydrocarbon pump. Again, on the left side, the customer sample, and just on the right side, the reverse engineered part. This is the stepping box. As you can see here, the damaged area, it is totally corrosion. And here the reverse engineered stepping box. Bearing housing we have here. This is the customer sample. Then this is the reverse engineered bearing housing. Finally, here we have the open type impeller. Sometimes the customer cannot let go the spare part because they still need it. But however, if the customer has the 3D model, still we can develop workable piece, and this is what we did on this project. And this is the pictures for the manufactured piece. Okay, thank you, gentlemen. We have covered with you SMI about our SMI capabilities and additive manufacturing and how it could help you to improve your maintenance performance. And finally, I would like to give a special thanks to ASME on behalf of SMI family for this great opportunity to show our company capabilities.